Today's lesson is an introduction into polynomials. We are going to discuss some common vocabulary terms, as well as look at expanding some polynomials. So what is a polynomial? It is an addition or subtraction of terms with variables. So you can see the expression I have below it, a sub n, x to the n, plus a sub n minus 1, x to the n minus 1, etc., etc., etc. So it's basically adding or subtracting a lot of different terms. What you want to notice here is that this is the largest exponent, because then n minus 1, n minus 2 gets all the way smaller until there is no x at the end. When it is written in descending order like it is shown here, that is known as standard form. So whenever you write your polynomials, you need to write them in standard form, meaning that your exponents are written in descending order. You also want to know that this a sub n right here, okay, is your leading coefficient. It is your leading coefficient because it is the coefficient on the term with the largest exponent. So when it is written in standard form, it is going to be the lead coefficient. So leading coefficient is where the name comes from. Okay, so polynomial, adding a whole bunch of things together. When it's written in standard form, that is written in descending order of your exponents, and the leading coefficient is the very first coefficient when it's written in that form. Okay, so then if I take a look at classifying polynomials by degree, okay, degree just stands for the largest exponent. Okay, largest exponent. So if it is linear, that means the largest exponent is 1. Okay, so that should make sense. So an example would be just x. That would be a polynomial of degree 1 or linear. Quadratic would have the largest exponent to be 2, so that would be an x squared for your largest exponent. I might have like a plus 1 after that, meaning x squared is still my largest, making that quadratic. Cubic, largest exponent is 3, so I could have x to the third plus x squared if I wanted, just where the largest exponent is a 3. And quartic is a 4, so that could be like x to the fourth plus x. Okay, largest exponent is a 4. So when we're talking about degree, linear, quadratic, cubic, quartic, we're talking about the largest exponent. I can also classify by the number of terms I have. So monomial means we only have one term, like x. Binomial means 2 terms. So how about x plus 1? Trinomial, you guessed it, 3 terms. So how about x squared plus x plus 1? And anything more than 3 is poly, meaning many, nomial. Okay, more than 3 terms. So how about x to the third plus x squared plus x plus 1? Okay, so 2 different ways to classify it, number of terms and then the largest. So let's practice classifying those. So when classifying, the first thing I need to do is write it in this standard form. So I'm going to find my largest exponent, which is my 4, and put that out front. So negative 8x to the fourth. Then my next largest exponent, so 6x to the third. Then my next x after that, and then my integer at the end. So this is now in standard form, meaning that 4 is my largest exponent, so we call it quartic. Okay. Number of terms, 1, 2, 3, 4, makes that a polynomial. And then the leading coefficient is this number out front, is a negative 8. So I'm going to call that a quartic polynomial with a leading coefficient of negative 8. Okay, so degree, again, the largest exponent of the terms of the variables in any term after the polynomial has been simplified. Okay, key idea here, after it has been simplified. So if you can put like terms together, you need to do that before you find the degree. So a few more practice problems. Put it in standard form first. What I want you to notice in number 1 is now for the first time we have 2 variables on the same term. So the degree of that one is the addition of those 2 exponents, which makes that a 7. So that makes my first term when I'm writing it in standard form, because then 7 would be my highest degree. Then I would have my x to the 5th, and then I would have my y to the 4th. Okay, so again, like I said, that's a 7 right here. And we don't have any special names, so I'm just going to call that a 7th degree. Okay, so after quartic, everything is just the number. Then I have 1, 2, 3 terms, so that's a 7th degree trinomial. And then the leading coefficient is 12. Okay, that number out front. Okay, number 2, what I want you to notice is that first we have to put together our two terms, like we just talked about simplifying first. So I have 6x to the 5th y minus 23xy. So to find my degree, I have to realize that that y has a 1 as an exponent. So if I add those together, that's a 6. So that's a 6th degree. Now that I have simplified, that's only two things, so it's a binomial. And the leading coefficient here is 6, that number out front. Okay. And last but not least, number 3, again, thinking about if I have two variables in the same term, then I'm adding that. So that one's a 10, this one's a 4, and this one is a 5. So this is close to standard form, but not quite, because my negative 7x y to the 4th needs to be second. Okay, so then the 7 and the 3 here gives me a 10th degree. 3 things is a trinomial. And my leading coefficient is my 11 from out front. Okay, so there is our terminology for polynomials. Then we're going to remember how to expand them. So if I have the quantity 2x minus 7 squared, remember that means that there's 2 of those parentheses, and then I need to FOIL. So I get 4x squared minus 14x minus 14x plus a 49. Putting together those like terms, that would be minus a 28x plus a 49. Okay, that should be a review for you. If you were one of the people who went straight from here to here remembering that trick, then fantastic. Okay, number 2, similar, another 4x plus 5 here. And then I will do the trick for you on this one. So that's 16x squared. Then the trick was to take the outsides and double it. So 20 times 2 is 40x, and then plus 25. If you don't like that trick and you did it your own way, you should still get that same trinomial. Number 3, getting a little bit more complicated here. So I should have a 7 minus x times another 7 minus x. That we're going to do first before we multiply it by the 2 minus x. So first I have to do this guy. I'm going to FOIL those. So that's 49 minus 14x plus x squared. And then I'm going to take that answer minus 2 minus x. So now I have a trinomial being multiplied by a binomial. So I need to take everything in the trinomial and then multiply it by everything in the binomial. So the first one is 49 minus 2 is 98 minus 49x. Then I'm going to take the negative 14 by both of those. So that'll give me a negative 28x plus 14x squared. Then I'm going to move on to the x squared times each of those. So plus a 2x squared minus an x to the 3rd. So remember, if I have an x squared times an x to the 1st, that you add those exponents, and that's where I got an x to the 3rd. Now I'm going to put together my like terms, and then in standard form, so I've got my negative x to the 3rd is going to go first. I have 16 total x squareds. Put my x's together should give me a negative 77x, and then plus my 98. So that's a cubic polynomial with a leading coefficient of negative 1. All right, number 4, I've got b plus 7 quantity to the 3rd. That means there's 3 of these fun binomials. So we're going to have to do the first 2 first and then take that answer by the 3rd. So if I FOIL those, I'm going to get b squared plus 14b plus 49. And then times b plus 7. So again, I'm going to take my b squared times everything. So b to the 3rd plus 7b squared. Then the 14b by both of those plus 14b squared plus 98b. Then I'm going to take the 49 by the b and the 7 plus 49b plus 343. Put those all together in standard form. B to the 3rd Put my b squareds together, plus 21b squared. Put my b's together, 147b plus my 343. Okay. Hopefully not too tricky, just maybe a little bit of work here. Let me circle my answer so you can see that. Okay, then I want you to try number 5 here. Pause the video and then check your answer. Okay, so if you did that one right, you should have negative 5x to the third plus 7x squared plus x minus 3. If you didn't get that, maybe ask your partner. Otherwise, I can help you when I get back. Okay, then we're going to just look at some polynomial functions, so some things that we a little bit longer than we've seen before. Okay, a 5th degree we haven't really looked at, so we can do similar things than we have done before. P of negative 1 just means to plug in negative 1 for all of my x's. So I'd have negative 1 to the 5th minus 4 times negative 1 to the 4th plus negative 1 squared minus 5 times negative 1 plus 50. Be really careful with your parentheses here. If you do it correctly, you should get a 51. Number 2, find p of 0. Plug in 0 for all of that x's. Okay, hopefully that's easy. That should give us 50. Number 3, I would like you to try using that on your calculator. Make sure that you know how to change the window range between negative 5 and 5 for the x's and between negative 60 and 60 on the y's. And you should get something like this. Okay, we're going to look a lot more at these. I just wanted to make sure that you remembered how to graph those and that you can change your windows effectively. If you struggled with that, again, talk to your pod partner. Okay, and then everyone's favorite real-life applications. So first one, Lori invested $150 at the beginning of each year for 5 years. There were no additional deposits or withdrawals. If Lori had earned 3.9% interest, how much was at the end of the 5th year? Okay, so I kind of start these problems like this. I had 5 years, right? So I had 150 times some interest, plus 150 times some interest, plus 150 plus some interest, 5 times, right? So her first year, second year, third year, fourth year, plus her 5th year. Okay, so then if I'm saying at the end of the 5th year, and this is her 5th deposit, this was her first over here, this last one, her 5th one, if it was the end, would get interest for 1 year. Meaning the 4th year would get it for 2 years, the 3rd year would get it for 3 years, the 4th year would get it for 4, and the first one would gain interest for 5 years. So that would be my polynomial, the $150 gaining interest each of the year that it was in there. And if I'm earning 3.9%, that would be the decimal 1.039. So I would just plug in 1.039 for x. The nice thing about polynomials is that instead of writing the whole thing with 1.039 in for x each time, I could just write x and then tell me what x equals. So plug that long thing into your calculator, and I want you to try to make sure you can get this right. It should be $842.45. Okay. Something similar, number 2, Mark received $250 on his 16th birthday. On each birthday after his 16th, he received increased by $50. He put it in an account paying 7.2% interest and did not make any withdrawals or deposits. How much did he have on the day he turned 20? So let's go, his 16th birthday was 250 times some interest, so that was 16. On the 17th, he get 50 more dollars, so it'd be $300 times some interest. Plus his 18th birthday would be $350 times some interest. His 19th birthday would be $400 times some interest. And on his 20th birthday, it would be $450 times some interest. Well, if it's on the day he turned 20, that money didn't get any interest. His 19th birthday got 1, his 18th got 2, his 17th got 3, and his 16th got it for 4 years. 7.2 would be 1.072 for that interest. And if you type that in to your calculator, you should get $1,980.75. Excellent. And one last one is a piece of metal was 36 by 25. It was made into a box by cutting out squares of x by x from each corner, so find the volume. So volume is length times width times height, right? So I need this dimension and this dimension. Well, if I know that this whole length is 36 and each of these pieces is x, I would say that this is 36 minus 2x. Similarly, my width would be 25 minus 2x. So I could find the area by multiplying 36 minus 2x by 25 minus 2x. And then length times width times height, well, the height is at x. So I'm just going to multiply that answer by x. So why don't you pause that and see if you can get the right answer. And you should get 4x to the third minus 122x squared plus 900x cubic inches. Okay, so an introduction to polynomials. Hopefully everything today went pretty well.